Okay, Debye Huckel limiting law. According to Debye Huckel, ants in a solution obeys Coulomb's law of the force. That is the force of attraction, repulsion existing between the ion is directly proportional to the magnitude of the charge. According to the Coulomb's law of the force of attraction, repulsion existing between the ions is directly proportional to the magnitude of the charge and inversely proportional to the square of the distance separating them. The force of attraction directly proportional to the magnitude of charge and inversely proportional to the squares of distance separating them. Let Q1 and Q2 are two charges separating by the distance r, then F equal to 1 over d, Q1, Q2 over r squared, where d is the dielectric constant of solvent. Because of charge separation, certain potential EI will be created on the surface of ion and its magnitude is given by EI equal to zeta ek over d 1 over kai equation 2 where zeta valency of ion electronic charge. K equal to root over 4 pi e square summation ni zeta squared over dkt. K is constant and 1 over k determines the thickness of ionic atmosphere, Ai ionic diameter. The free energy is created on the solution side due to potential Ei, which is given as Fe equal to minus Zi squared E square K over 2D 1 plus Kai equation 4. Again, the quantity Kt ln Fi represents the difference in free energy change obtained by the addition or removal of 1 gram ion of the given species from a large volume of real or ideal solution. This difference may be considered as equivalent to the electrical energy of the ion due to its ionic atmosphere, so that equation 3 becomes KTLN of Y equal to minus zeta square K over 2D 1 plus KAI, or ln of Y equal to minus zeta square K over 2D KT 1 plus KAI, equation 5. If Ni equal to Ci n over 1000, then again from the equation 3, K equal to root over, we have substituted the value of Ni value of Ni in equation 3 by the Ci n over 1000. So solving will get root over 4 pi e square mu 1000 dkt, where mu equal to half summation Ci zeta squared. Now substituting the value of K from equation 6 in equation 5 becomes ln Fi equal to minus a zeta square root m over 1 plus Bai root m, equation 7, where a equal to e cube over 2.303 root over 3 by 2 dkt root over 2 pi mu over 1000 and b equal to root over 8 pi square mu over 1000 dkt. On solving equation 7 for mean activity coefficient, log 10 fi plus minus equal to minus az plus z minus root over mu over 1 plus bi root over mu, where ai average ionic diameter for dilute solution bi root over mu is the small compared to the unity, and hence it may neglected. Log 10 f plus minus equal to az plus z minus root over mu. Debye Huckel limiting law relates the mean activity coefficients of an electrolyte with valency of cation and anion and an extent of the medium. This relation is applicable only for very dilute solution. So this law is called limiting law. Mathematically, also we can write log f plus minus equal to minus a z plus z minus root over mu, where f plus minus mean activity coefficient, z plus valency charge of cation, z minus valency charge of anion, mu ionic strength of medium, a constant that depends on the temperature and dilute constant of solvent for water at 25 degree, a equal to 0.509. This equation is in the form of y equal to mx plus c, when minus log f plus minus is plotted against root over mu. We get a straight line passing through origin, and slope of this line equal to az plus z minus. For 1:1 electrolyte, z plus z equal to z minus equal to 1, slope az plus z minus a11 equal to a. For 1:2 electrolyte, az plus z minus a1 to 2a, 1:3 electrolyte, slope az plus a3a. Okay, it's all about Debye Huckel limiting law. Thanks for watching, and request you all like, comment, share, and subscribe. Thank you for facing. That is now. Bye bye. See you again.